Right, for the next step of this, we now want to go beyond just being able to picture whether there's a relationship and now being able to statistically verify whether there's a relationship between the data we've got. So in this spreadsheet, I've now got the same countries with their remittances and their HDI values, and we're going to calculate what's called a Spearmans Rank correlation coefficient. So to be able to do this, I need data that is paired. And by that, it means that for each of my data points, in this case countries, I've got two pairs of data. I've got one bit that's the remittances and one bit that's the Human Development Index. So I fulfill those criteria, that's a tick. Secondly, I want a data set that's got more than about 10 countries in it. And that's because if I've got a really small data set, I'm not going to be able to draw any statistically significant conclusions from this. So again, I've got a big enough data set here. I've got 30 countries that are involved. And lastly, I need to be able to have data that I can rank. Now, these data on here, I can put in an order, and that's really important for this test. If I can't order data, so let's imagine I had level of development, and it was just a 3-option choice between AC, LIDC, and EDC, then I'm not able to rank those. Whereas these ones here, I can rank in order from the biggest to the smallest. So first off, I'm going to talk you through how you would go about this. And you'd first off decide to write a null hypothesis, something that we're going to try and prove or disprove. So my null hypothesis here would be there is no significant, let's see if I can spell, no significant difference between remittances as a percentage of GDP and HDI. So that's the null hypothesis. So if I don't want the null hypothesis, I need an alternative hypothesis. So there is a significant difference between remittances as a percentage of GDP and HDI. And that means I can refer back to these hypotheses as I work through the test, and I can prove or disprove them as I go along. So moving forwards, I'm going to take these countries then, and I'm going to try and rank these countries. So in the moment they are in alphabetical order, but I want to rank them by the 2 bits of data. I want to do some separate ranking. So I'm going to start off by ranking their remittances. So what I'm going to do is I'm going to create another column. So if I highlight C, I right click, I press insert, that'll insert a column in here. And I'm going to call this column here rank for remittances. Now there's a couple of ways I could do this, but my favorite way of doing this is I'm going to highlight all of my data and I'm going to rank these by their remittances. So if I go up into the top here, I've got a sort and filter. If I go into custom sort, I'm going to sort them by column B, which is the remittances received. That means they're going to order up from the highest to the lowest, or vice versa. So I'm doing it by remittances received, and I want to go from, let's go the other way around. I want to go from the largest to the smallest. So this has now moved all my data around and all the paired bits of data with it. So it's got my biggest remittance at the top, 28.8% of the GDP, and it's moved Nepal, the country that had 28.8%, up to the top as well, and has also moved Nepal's HDI value up the top. So I've now got these countries over here, no longer ranked alphabetically, but now ranked by their remittances. So in here, I can do a couple of things. I could just type the numbers in, 1, 2, 3, and I could work my way down. That would be quite long and manual. I could highlight the top 3, click the little green box in the corner, and I could left click and drag down, and that would drag all my numbers down the bottom. I'm going to do that way for this one. That's nice and easy. But what I do need to check is I need to check that there are no tied ranks. So if I go through these numbers on here, I'm looking to double check that there aren't any that are the same on here. Because at the moment I've just got the numbers 1 to 30, but if there are any ties, I'm going to have to sort out those. So 28.8 is different from 21.1, is different from 20, is different from 19.7. So I'm fine here. I'm going to go down. Here we go. Montenegro and Sri Lanka both have 9.6. So what I need to do here is I need to work out what I'm going to put as these two, because these aren't 8 and 9. That would be unfair. They're both the same value on there. So I'm just going to take their average point. They were positions 8 and 9. So I'm actually going to call them both 8.5. So 8.5 and 8.5. And I'm going to go down and I'm going to check, see if there's any others. I've got another one here, 2 0.6. So instead of 21 and 22, they're both going to be 21 and a half. Do I have any more? I've got a couple more down here. I've got another one in here. And another one on here. 28.5 and 28.5. If I'd got three numbers that were all the same, so imagine Argentina, the UK, and the USA were all 0.1, and they were positions 28, 29, and 30, well, the average of all those three numbers is 29, so I'd just put 29 in for all three. So now I've successfully ranked all of the remittances, and now I need to do the same thing for the Human Development Index. So I'm going to do the same as before. I'm just going to give myself an extra line because I know I need a few more. I need a few more columns in a minute. So this one in here is going to be HDI rank. So perhaps you can try and do this before me. Stop the video and see whether you can do this. Right, so to do this, I'm going to again highlight the whole of the data set. In here, I'm going to go sort and filter. I'm going to go custom sort, but this time I want to sort by the Human Development Index. And again, I want to go from the biggest to the smallest. So I've got my biggest up at the top again, which is Germany at 0.991. I'd expect a big AC at the top to be high up my Human Development Index, and Mali and LIDC down the bottom with 0.407. So again, I'm going to do the same thing. I'm going to do my ranks. I'm just going to highlight that, drag them down. I've got 30 numbers, and I'm just going to double check as I go down here that I've not got any identical numbers on here. Dun, dun, dun. Have I got any identical ones? I do. I've got two down here. So 25.5, 25.5. Perfect. I've only got one in that case that is ranked the same. Excellent. So the next thing I need to do, it really doesn't matter what order I leave these countries in. At the moment, they're ranked by their Human Development Index, but I could rank them by absolutely anything. The next part really doesn't matter. So I'm just going to stick them back in as alphabetical order, just to remind us how to do things and sort things. So again, custom sort again. This time I just want to rank them by, I haven't got all of them. Let's grab the whole lot. I want to custom sort. I'm going to rank them by column A. I didn't actually have a title in there, which is why nothing's coming up. And I'm going to put them A to Z. So let's put a top in their country. Right, so I've got them all ranked. I've got them all ranked by alphabetical order now. So country, remittances, remittance rank, human development rank. The next thing I need to do to calculate a Spearman's rank correlation coefficient is work out the difference between the ranks. That means the difference between the rank in the remittances in column C and the rank of the HDI in column E. So I'm going to call this one difference of ranks. And in this column here, I'm quite simply going to do one subtract the other. So I'm going to put equals, and I can click the box, or I could write it in, it's C2, but I'm going to click the box equals C2 minus, and then E2, and I'm going to, again, click the box. I could write this in E2. So I'm just going to press enter, and that will come through 28.5 minus 8 is 20.5. So quite simply, I'm going to use the magic of Excel. I'm going to click the cell that I've got an equation in, comes up with that little green box in the bottom right hand corner, and I'm just going to left click that bottom right hand corner, and I'm going to drag that down the whole way down here, and that will very handily for me move that formula all the way down. So if you can see right at the top, it says up here equals C2 minus E2. When I go down a box, this one here equals C3 minus E3, down again equals C4 minus E4. It filters down for you as you're moving down. The equation will automatically change. The next thing I have to do with this test is I have to square the difference of the ranks. So multiply itself by itself. So this is going to be difference squared in here. And to do that, I can do equals F2, that value in there, times is the little star found above the number 8 on the keyboard. So shift 8 gives me my star. F2 times F2. Okay, that will square that value for us. And I'm going to do the same thing. Can you drag that formula all the way down without me telling you how to do it? good to just click on that one, grab the bottom right hand corner and drag it all the way down to the bottom. So now I've got all the differences squared in here. So this is actually, this little image here shows you the how to calculate the test statistic for a Spearmans Rank correlation coefficient. So I need to basically work out this bit on here. So I'm just going to drag this down so we can see this a little bit more clearly. I've got a bit more space down here. And I need to work out the test statistic, I have to do 1 subtract 6 times the sum of, that's what that figure on there means, the sum of d squared, the different squareds, divided by the number of data I've got cubed minus n. So we'll take this a bit at a time. So firstly, the sum of d squareds. Well, all my d squareds are up in here. So to calculate the sum of d squared, let's do that in here. So I want sum of d squared. So to work out the sum of d squared in here, I'm just going to put in a new equation, equals the sum of, just typed in sum, open brackets, and then I'm going to say I want all of these cells added together. So I've just left click, drag down all of those cells, close brackets. So that says equals sum, SUM, equals sum, open brackets, G2 colon G31. That means add up all of the cells in between G2 and G31 and press enter. So that comes through there with a number that doesn't really mean very much to me at the moment, but is 7,536.5. Now at the top here it says I need 6 times that. So let's just put in here, I'm going to times that by 6. So equals that cell times by, remember that was the shift and 8, the star, times by 6. So 6 times that number in there is 45,219. So let's work out the denominator down here. And we need to do n cubed minus n. So I'll just n cubed minus n in here. So we know how to square something, so just add it in again and we can cube it. So equals n, we know we've got 30 countries, so we know it's 30 times 30 times 30, and then minus 30. So that gives me 26,970. And now to work out this fraction, I need 6 times the sum of d squared divided by n cubed minus n. So there's my 6 times the sum of d squared. There's my n cubed minus n, and I just need to divide one by the other. So in this bottom one, I'm going to say in here, this is the bit where I divide, and I want to equals, and there was my value on top. There's 6 times the sum of d squared divided by is a forward slash, and then I want divided by n cubed minus n. So that gives me a value that's 1.6766. There might be a few more digits if your box is longer. And then to finish this off, I need to do 1 subtract that. So I'll just put here 1 minus that. So I'll do equals 1 minus, and then this cell that's in here. Bingo, I have got myself now a test statistic. So it doesn't mean a lot at the moment, but that's an important number in there. So I'm just going to highlight that in yellow so we can see it. And it comes out as minus 0.677. So first of all, I'm going to go back and I'm going to have a look at this bit in here, which says that if my number is close to 1, then I'd expect a strong positive correlation. If it's close to 0, I'd expect no correlation. If it's close to -1, I'd expect a strong negative correlation. Well, the first thing I notice is obviously it's a negative number. Now, when we drew the scatter graph earlier on in the lesson, we should have noticed a negative relationship. That line of best fit went from somewhere up in the top left-hand corner of the graph down into the bottom right-hand corner. That is a negative. So that's one thing we can check. Have we made a mistake? Because if this had come out as positive, we'd know we were doing something wrong there. Now, I'd also say that 0.67 looks like it's closer to 1 than it is to 0. But what's the value we need to get to statistically prove that there really is a relationship in here? Now, that's where we have to compare our test statistic to a critical values table. So I will go and have a look at a critical values table. I've got one over here, and I will have a look at my n value on here, and I know I had 30, so conveniently that's the bottom line for me. And what I will be doing now is I'll be looking, I'll ignore the whether it's a positive or a negative number. I'm just looking at the size of the number now for the graph, for the comparison to the table. And the size of this now is 0.676. So if this number is bigger than the numbers that you find on the table over here, then we can say that there is a relationship at that between those two variables. So let's have a look to see whether there is a relationship between our remittances and our HDI. If we go over here and we are looking at, I'm going to look initially at this 5% level. And what does that really mean as a percent? Well, that means that I could, imagine I threw a load of darts at a scatter graph that was a scatter graph between remittances and HDI. Well, I could, by fluke, throw my darts into a straight line and they created a perfect relationship. Now that's luck. I've done that by chance. You can get relationships sometimes by complete fluke. Not because there really is a relationship between the two, but just because the data happens to appear like that. So what this 5% is saying is it's saying, I understand that there's a 5% chance that the relationship I'm saying is there has just happened by chance. Maybe there's not an underlying relationship. I'm 95% sure, statistically, that that relationship does exist and that there is a correlation between my two variables. But I'm 5%. I've got 5% in the bag for, oh, maybe that happened just by chance. So you can look at it at different percentages. So a 5% failure rate and a relationship by chance is pretty decent. But I could, if I wanted to, have a 1% chance over here and a 99% that I'm sure that there is a relationship. And it's not a fluke, but there is a relationship between those two data sets. But I need to get a bigger number to ensure that. So my number that I got out here was 0.676. So if I look over here at the 30, 0.676 is bigger than any of these numbers on here. So I can actually say that not only am I happy at the 95% confidence or the 98% confidence level, but I'm actually happy at the 99% confidence level that there is a relationship between these two variables and that remittances and human development index are somehow statistically linked together. So what I'd do then is I'd go back and I'd say my next stages would be, is the RS value that I've calculated bigger than the critical value? And the answer is, for me, yes, it is. Remember, I'm not fussed about whether it's negative or positive. I'm just looking for the size of it. So yes, it is. Now, because it's a yes, I can therefore say there is a significant correlation between remittances as a percentage of GDP and HDI. So I am going to reject H0, my null hypothesis at the beginning, and I am going to accept H1, my null hypothesis, which is that there is a significant correlation. So quick couple of things with this. If you ended up with a number in here that was just positive and just came out with 0.67, I go through the same process, but I'd say it's still bigger than the critical value. There is still a significant correlation, but the correlation is just a positive one and not a negative one. Imagine that the number that I'd got in here had come out as 0.214. I'd then take that up to the top. 0.214 would be smaller than all of these values in here. And because it was smaller than all the values, both at the 5%, the 2%, and the 1%, smaller than all of them, there's the smallest one, 0.364. 0.2 would be smaller. I would come through in here and I'd say, is RS bigger than the critical value? No. And I'd write in here, there isn't a significant correlation between remittances and HDI. I will stick with my null hypothesis, and my null hypothesis that there's no relationship will remain true. Lastly, why does this happen? We don't need to understand the maths behind this. This is a geography course, not a maths course. But put very briefly, if you're looking at the differences between these ranks, fundamentally, if you want them to be, if there was a perfect relationship between these two, and they came in this perfect straight line, well, then all the ones with the highest rank remittances would also have the highest rank HDIs. There'd be no difference between the ranks. They'd always appear as 1 and 1, 2 and 2, 3 and 3, and you'd get 0 as the difference of the ranks in here. When you added all of those up together, your sum of all those 0 values would effectively be 0. So the value at the top down here in your equation would be a 0. If you're doing 1 subtract 0 over any number down here, you're going to end up with a test statistic that's 1. So a perfect relationship is always going to be up at the value of 1 or -1 if it's a strong negative correlation. But you're always going to get a value that is close to 1 for being like a really strong relationship. Like I said, the math behind it is irrelevant. It's the geography behind it that's really important. And the only bit that we need to know is the process of doing this. Would you need to be able to do this in an exam? There's no reason why they might not give you one of these with some gaps in it and ask you to fill it in. Or more likely, they might give you something like the sum of d squared and the number of bits of data and ask you to complete this bit in here instead. And ask you to interpret some results. But you may well decide that in your projects, for example, that you end up doing a Spearmans Rank test. So you need to be able to do this as on your own. So hopefully that's helped you understand what to do for a Spearmans Rank test. Have a go on your own.